Okay, welcome back. We have a lot going on today. So we are looking at the concept of standard deviation. Now, this is an important one. Standard deviation is kind of an underlying concept or an underlying idea for a few of the things that we're going to be looking at in statistics. So it is one we kind of have to go over in a bit of detail. But it's not one that's entirely hugely tricky. There's just a little bit to it, and it has a quite importance, I suppose, in statistics generally. So standard deviation, the word deviation, or if something deviates, it just kind of means it's different. It kind of differs slightly or largely from something else or from the norm. And that, I suppose, is a good understanding, really, of what standard deviation is. It's a measure of how spread out our data is. So the measures of spread we've looked at already would be like range or interquartile range. So this is just another measure of spread for our data. And what it tells us is it tells us the average distance of the data from the mean. So how different is my data on average from, I suppose, essentially the average value, the kind of middle norm average value that I could get. How far away from that value is my data? Okay, kind of overall as an estimate, really. And we use the symbol here as a little kind of circle. Oh, I'm using my mouse, you can't see that. It's like a little kind of circle here, a little kind of O with a little tail. It's sigma, it's the symbol, it's the Greek letter sigma. We use that symbol for standard deviation. Okay? Low standard deviation means the data is all close to the mean. So we would say it is a small variability. Okay, so it's all quite close to the mean, it's all quite close together. High standard deviation means it's quite spread out, there's large variability within my data. Okay, we generally would think of this as a better measure of variability because you use all the data in calculating it. If you think back to what we did with the range, we just used the first and the last data point, and we talked about how an outlier could really throw that off. Even the interquartile range, we still use more data to work it out, but it still does come down to maybe those 2 or 3 points that you use, calculating the median first and then using that to kind of get the other two middle ones. But really, at the end of the day, I suppose you're really using two data points again. So this gives us a more accurate measure of how spread out my data is. To find standard deviation, you have to be able to do it on your calculator. Okay, there obviously is a method to do it by hand, but for your curriculum, we need to know how to do it on the calculator. And I've put in a link or QR codes in your notes to some lovely videos on YouTube, not by me, but people explaining how to use your calculator to calculate standard deviations. I've put in the three brands of calculator that I suppose are kind of the most common at the minute. The first one is kind of on its way out. The second one, honestly, is also similarly on its way out. So what I'm going to use for the video is I'm going to use the new one for the video, and in terms of just when I'm calculating it on the calculator, I'm going to use the new one, just so that we can see how it works there. Obviously, you can watch those videos separately to make sure that you're content with how you would calculate it. But just so that we can go through calculating one and talking about what it means, I'm going to use the new one for longevity purposes for this video. So when we're calculating statistics, so let me see. You can't see my mouse there, can we? We can't. Okay. So when we're calculating statistics, this is going to be important. So when we're calculating statistics, or anything to do with statistics on a calculator, we need to go to the statistics mode. So this menu, I suppose, should be coming up. I'm going to click the right arrow so that I can go over and go into kind of the statistics section here. So I'm going to click OK to go into that one. Then we come to this one variable and two variable. And we talked about this a little bit when we defined different data, and we looked at kind of univariate and bivariate. So univariate data has one characteristic or one thing about it. Bivariate is where there's two things. If I'm just going to look at a set of data here, and I'm going to use these red numbers that I've written in on the notes here, I'm going to use these notes. There's only one piece of information for each data point. So I have 3 as the first one. That's all there is. It's 3. Okay, there's nothing else tied with it. So it's only one variable. So I'm going to go with one variable here. Now my table is coming up with an option for frequency as well. That's something that comes up a little bit later if we need it. But generally we'll leave our calculator on that setting. And all that it really refers to is how often is a number there. It's another way of us writing it in without having to repeat the number. So all I'm going to do now is fill in the numbers that I have. So I have the number 3, and I'm going to press this execute button to kind of fill that in. and we see it comes up frequency of 1, it's there once, I'm content with that. I'm going to go with 10, lovely. I'm going to go with 12 next, then I have 15, then I have another 15. Okay, what I could have done instead there was only put in the 15 once but change the frequency to 2, but it's much easier to nearly just put it in, particularly for a small data set like this, to just put them all in. 24 lastly, and there I go, and I have all my numbers filled in. Okay, now that I have all my numbers filled in on this calculator, all we're going to do is press this execute button again. Where that brings me to now is my one variable results and my statistics calculator. I just want the results. I want the answers. I want to see what the kind of result was, I suppose. And we actually end up with some really, really interesting results here. The calculator presents us with quite a lot of information. So even just to kind of quickly go through what it all means, okay, what they're kind of giving us. Let's see, can I zoom in here at all? I can. Okay, so looking at kind of what we have here, what information they're giving us, the first thing they've given us is up the top they have an X with a line over it. That is what we call X bar. That's going to come later in our chapter here, but for our own purposes here, what it refers to is the mean. It's the average, okay? It's kind of the mean value for this data set, and they're saying here the mean is just over 13. It's not a whole number, but just over 13. If I look at my data set, that seems fairly accurate, I feel. I suppose we have, looking at our data set now, we have a lot of numbers in the middle there, 10, 12, 15, 15. We have a 24 to one end, which is slightly larger. We have a 3 to the other end, which is slightly smaller. So those two things kind of throwing things off a little bit here. But definitely that kind of middling value of kind of in around the 10 to 15 there. So 13 feels kind of spot on for that. The next one, this actually refers to the sum of all of the values that I typed in. So if I added them all together, the answer would be 79. We're going to skip over the next two. The one we want is the very second last one here with the sigma symbol and the X. So the second last one there is the one we want. So they're telling me that sigma for these values, the standard deviation for these values is 6.309164441, and obviously our calculator is only going so far. I'm going to go to maybe 2 decimals, so 6.31. So they're saying there, what this basically means is that my data is fairly spread out with a standard deviation of about 6.3. And what that means is on average, my data points are around about 6 units from the average value. Now we said here the average value is 13. So obviously I have some data points that are quite close to that are only maybe 2 away or 3 away. But then I do have data points that are 9 away or 11 away, or data points that are 10 away on the other side. So obviously those are going to impact our standard deviation here. So when I look at it, 6 seems reasonable because I know, yeah, I have a few that are in the 2s and 3s, but I also have ones that are in the 10s, that are in the 11s. So 6 seems like a reasonable measure of variability there for me. So we can see how important it is for you to be able to not only calculate that on your calculator, but also to interpret it, to know which one it is also part of it too. So to know which one we were looking at there was really, really important. So it's the second last one with the little sigma symbol, but also even just to be able to interpret that slightly as well, just to kind of really think, does this make sense as an answer for me here? So let's get into some of the examples here, some of the exam questions. We're just going to look at that in practice a little bit more with some of our other ones, our mean, our standard deviation, our range, all of these, pulling it all together. So the table here shows monthly rainfall for Athenry. Each value is rounded to the nearest millimetre. We're asked to find the percentage decrease in rainfall from June 23 to June 24 and give our answer correct to 1 decimal place. So let's just find what the decrease was. So the decrease in rainfall is 94 minus 72, which is 22. We're going to put that over the new rainfall that we have, which is 72, and times 100. I'm just going to use this calculator while we have it here. So let's do that. So 22 divided by 72 times 100, and that is going to give me, to make this very awkward, 30.5. So they said to 1 decimal place, so 30.6%. 30.6%. Work out the mean and the standard deviation of the total monthly rainfall for Athenry from the table above. Give both answers correct to the nearest whole number. So if we were paying attention there, when we used our calculator, we were actually able to see all of those values. Now the mean is one that we can work out fairly easily. So let's do our work for the mean, but we'll have in our head that we could do it on our calculator. So when we go to do standard deviation, it's going to give us the mean anyway. So that can be a nice check for us to make sure that we either have got the mean right by doing it by hand, or that we haven't made a mistake typing it into our calculator, which is another option. So let's look at the mean here. All that I need to do for that is to add up all of these numbers that they're giving me. So let me see, can I type these on the keyboard? Would be a bit handier. 42 plus 186 plus 93 plus 64 plus 94 plus 224 plus 129 plus 148 plus 180 plus 114 plus 203. So they're telling me here that the total there for what I've added is 1591. This is just across 1 year, so that is out of 12 months. So we'll divide by 12, and let's just work out what answer we get there. That's going to give me an answer of 132.583. They're saying both to the nearest whole number, so that would be 133 millimeters. For standard deviation, we have to use our calculator. So let's do that. We press the home button first, then go to my statistics, one variable, list out my answers. I'm going to clear these if I can. No, that's not going to clear them there. So let's just kind of clear them. I'm going to delete them all here. And I'm going to just clear them as I go. So let me see, let's type them in. 114 and execute. 42, execute. 186, execute. 93, 64, 94, 224, 129, 148, 180, 114, and 203. Okay, I've entered them all. I have 12 values. That seems good. I'm going to press my execute again. I'm going to go into my results. And let's just look and see. First of all, they've given me a result for the mean, and we can see that what they got does match with what I got. So I'm happy that number one, my calculation for mean was correct, and number two, that I have entered everything into the calculator correctly. I haven't mistyped any digits because my two values do match for the mean there. So let's just take the value for standard deviation. It's the second last one there, 54.2547, and they said to the nearest whole number, which here would be 54. So 54 millimeters. So what we're getting there is there was an average of 133 millimeters with a variability of around about 54 millimeters on average. So anywhere within that range, and that could be plus or minus 54 is kind of what we're looking at here. So the next question is actually to do with interquartile, so we might as well give it a go. The upper quartile, they tell us, is 183. Find the value of the lower quartile and then work out the interquartile range. So to find the lower quartile, I have to find the median first. The median is the middle value. There are 12 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we already really know for an even value like 12, there's not going to be a kind of spot on middle value. We're looking between the 6th and the 7th here. So 1, 2, 3, 4, 5, 6. So between these two is my median. Okay, I can calculate the median, but for actually to answer the interquartile range, I don't actually have to get it because I will be ignoring it anyway. All I need to know is where it is and where I'm then kind of splitting my data in two. So I could also just go, well, it's going to be 2 6s here to kind of split it in quarters. So I have 2 sets of 6 here. So we're running actually into a similar issue now, wherein neither of these will actually have an even number of data points either. So looking at the first set of 6, I would be fairly happy to say that the median or the quartile is going to be in between these two values here of 93 and 94. So let's find an average there. You should probably be able to do it in your head. That's my quartile 1. The other side is between 180 and 186. and divide by 2, and that is going to be 3, 6, 8, yep, 6 divided by 2, 183. 183. So that's my quartile 3. So my interquartile range is 183 minus 93.5, and that is going to give me, let's use our calculator, why not? Nope. Guess that's why not. And it's 89.5. It's 89.5. Yeah, see that. From the time we'd have done it, it worked out anyway. Okay, so important, I suppose, thing here, really, our main takeaway, I suppose, from all of this is supposed to be standard deviation. So standard deviation is a measure of the variability, how spread out my data is. Low standard deviation, low variability. High standard deviation, high variability. Okay, and then using that in the calculation.